Okay, so if we have nicotine, nicotine is 74.1% carbon, 8.64% hydrogen, and 17.3% nitrogen. What is the empirical formula?
We're not quite there yet, Dr. Henry.
We're not quite here yet?
We were at aluminum chlorate
No.
is
Okay.
something.
So we are behind.
That one.
This one. Okay. So we were talking about the parts and the wholes, right? So we talked about percent composition. Okay, good.
Yes.
Okay, I'm just making sure okay, so here we have calculate the percent composition of the mass of aluminum sulfate. So what is the first thing that I want to do?
What does aluminum sulfate look like?
Okay, so we want to write the chemical formula for aluminum sulfate. So what does aluminum sulfate look like?
AlSO4. Is it 2 minus?
AlSO4. Okay, so now here again, this is one of the things that we want to stress, and I'll stress it again and again. When you're given a chemical compound, and you know that, is this an ionic compound or is this a covalent compound?
It's ionic.
It's ionic. Okay, so if it's an ionic compound, at the end of the day, the charges have to balance out. So they have to equal the total charge of 0. Okay, so I would write that down on my periodic table. So an ionic compound has to equal total charge of 0. Okay, so what is the charge on aluminum?
+3.
Plus 3 charge.
And what is the charge on the sulfate? I think somebody said that.
-2.
2 minus.
-2. Okay, so how many aluminum will I need to balance out the sulfate? How many sulfate will I need to balance out the aluminum?
2 and 3.
2 and 3. Yeah.
Now, I'm stressing this because I saw a lot of this on the exam, right? Even though that we specifically talked about it, you still want to fight it. Stop fighting it, right? Balance. Think about 0. Everything wants to balance out at the end. Everybody wants to be neutral at the end. Unless it says ion, it's going to have a neutral charge, okay? So we're going to need 2 of these and 3 of these. Is that correct?
That's correct.
Okay.
Yes.
So when they come together, because they're interacting together, right, they're going to be written like this with the subscript. There are a few people that wrote them like this. Okay, that's wrong. Okay, are we clear?
Yes.
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 You've never seen them written like this at all. You'll see it written like this, where they're separated, and this is showing that they're coming together, right, to form a single compound. Now, this is an essential part of chemistry. If you cannot do nomenclature, you're going to fail the class. I guarantee it. It's a guarantee. Because everything revolves around you being able to name the chemical compound, because you can't balance equations if you don't have the right chemical compound. You can't do anything if you don't have the right chemical compound. How can you tell a drug if you can't name what the drug is? Nomenclature is an essential part of it. If you're going into the nursing field, you need to know nomenclature. If you're going into the pesticides field, you need to know nomenclature. If you're planning to be a chemist, you definitely need to know nomenclature. Okay, so you want to put the time into it. Okay, so we got this down. Let me stop preaching. Okay, so what's next? What am I going to do next?
Find the molar mass.
Find the molar mass. Okay, so how would I go about that, Oscar?
So we break it down. So we have aluminum weighing at roughly 27.
And how many aluminum do we have?
2.
And
we have
47, 54.
54.
Okay.
And we have sulfur weighing at roughly 32.
And how many do we have?
3. Total 96. And oxygen weighing at 16.
And how many do we have?
We have 12. $192.
Okay. So then what do we do?
6. Add them all up.
Okay.
342.
The units are grams
Grams per
mole.
mole.
Okay. Okay, so if we're looking at aluminum, percent aluminum, how would I calculate that?
We'll do 54 divided by the total, 342, and multiply that by 100.
So you said 54. So just the aluminum divided by the total, 342 grams per mole. Grams per mole. And multiply by 100.
Correct.
Okay.
%15.8%.
Okay. Percent sulfur. Anybody else want to join in? Or is this just a me and Oscar?
96 over 342.
Okay. 96 over 342.
Multiply by 100. And your answer is 28.1%.
Okay. And oxygen?
It's gonna be 192 divided by 342 times 100 gives you a 56.1%.
Okay, piece of cake. So again, we want to remember it's the mass divided by the whole, right? I mean, not the mass, the part divided by the whole.
Yes.
Yes.
Okay, oops. So aluminum chlorate is, I remember, this is where we actually stopped off. Aluminum chlorate is 38.35% chlorine or chloride. What is the mass of aluminum chlorate? What mass of aluminum chlorate is needed as a source of 50.0 milligrams of chloride? So what am I going to do in this case?
Find the percentage of chloride of aluminum chlorate.
But why would I do that? Because don't they already give me that? Isn't that kind of,
Wait. Find the molar mass of the rest of it.
do I need to find the molar mass? What is this asking me to find?
Never mind. Hold on.
No, but I want you to know, Diego, you started, read the question. What is it asking for? What is the question asking for?
How much aluminum chlorate you need to have 50 milligrams of chloride?
So what unit are they asking for? Is it really how much, or is it how many, or is it the mass, or is it the?
It's how much, the mass. How
We're
much
looking for the
aluminum
mass, right?
chloride.
So we're looking
Yeah.
for the mass. So what do we know about percent mass? What is the definition of percent mass? Can somebody tell me that? Giselle,
Yes.
what is the definition of percent mass?
I don't know, Dr. Henry.
What do you mean you don't know?
I don't know what the definition is.
Think about it. Percent mass. What did I just talk about?
The percentage of the mass.
Think about it. I want you to take a moment and think about
Okay.
it. Putting you on the spot, Giselle, all right?
Okay.
But I want you to take a moment to think about it. So what did I just say? It's the what over the what?
Part divided by total.
The part divided by the total, right? That's percent mass. Okay. Part divided by the total. I don't say shit just to say shit. Dang it. What's going on? I know it's the first day of the week, right? For you guys. This is your Monday. That's what it is. That's what we're going to chalk it up to, being the Monday. All right. Okay, so we know it's the part over the whole. So what is the part that we're looking at in this problem?
38.35.
38.35. Wouldn't that be my percent mass? Would that be the part?
Aluminum chloride.
Aluminum chloride would that be the part, or would that be the whole?
It would be how much you want of chloride, or how much, I don't.
Okay, so we'll start with the definition. Let's just start there. So we said it's the part divided by the whole times 100. Okay, so what is the part? Just tell me the chemical or the ion or whatever the part is. What is the part?
Would the part be
Chloride.
It's going to be the chloride. Okay, so we want chloride and the whole would be
Aluminum chlorate.
the aluminum chlorate. What does aluminum chlorate look like? Or what is the chemical formula for aluminum chlorate?
AlCCl03 minus.
Okay. And how many of them? Okay. How many of them would I need
We
to
need
balance
3
out the aluminum? Because remember, it's an ionic compound, so it's going to have a total charge of 0.
3.
So I'll need 3 of them. Okay, so that's my part over my whole. And we know that that is going to equal times 100. That is going to equal my percent. This is going to be my percent aluminum. I'm sorry, percent chloride. Okay, so that's what we're going to have is our percent chloride in that case. Okay, so what do they tell us? What is this?
That's the percentage of aluminum chlorate that is
At the
chloride.
bottom.
Okay, so this,
Part is the
so Diego, are you telling me that this is my percent chloride that's in the aluminum chlorate? Is that what you're saying?
Yes.
Okay, so you're telling me that this guy, 38.35, is this here. Is that what you're telling me?
Yes.
Okay, so we can plug it into that equation, right?
Yes.
Okay. So what else do they tell us?
The rest of it is the question.
Okay, but there's nothing else that they're giving us?
A milligram
Milligrams of what?
of chloride.
Chloride.
So is that my part or is that my whole?
That's the part.
Part.
It's my part. So they're giving me this. So I have 50.0 milligrams of chloride. So this is what I'm trying to find out. I'm going to put a Y here. I want to know what my Y is. Okay, so how can I solve for Y? How do I do it in algebra? So if we just put the numbers here, we have 50.0 over Y times 100 equals 38. How would I solve for Y?
Get Y by itself.
So how do I do that?
Divide each side by 100 and multiply each side by 1 over 50.
Would that get, so then I'd have 1 over Y equal 38.35. Is that going to give me Y or is that going to give me 1 over Y?
Oh, no. Multiply each side by Y.
Okay, so let's multiply each side by Y.
Divide 38.5. 35.
So multiply it by Y times Y. So then that cancels out Y. So we get 50.0 times 100 equals 38.35 Y. And then you said divide everything by 38.35.
Mhm.
So then we get Y equals so how many sig figs should I have?
Three.
3.
I should have 3 sig figs.
Yes.
Okay. And what would be the units?
Milligrams.
Okay. Piece of cake. And you need to brush off those cobwebs, right? That algebraic cobweb that's sitting over you. Okay. Questions, concerns, Cash? Okay. Let's move forward. Okay, so let's talk about empirical formulas. Empirical formulas are, you guys know what lowest common denominator is, right?
Yeah.
Yeah.
Okay, what is it?
The smallest number that two different numbers can multiply into.
Smallest number that two numbers can multiply into. Are you sure multiply
That they're a
into?
factor of. That they're a factor of. Wait.
I guess I'm a little confused. Lowest common denominator. Right. So that they're a factor of. So two numbers that the lowest, you said, is it the lowest number?
Yeah.
Okay. So lowest common denominator.
Lowest
Okay.
common multiple.
Should I say the highest common denominator? How about that? So if I have 5 and 10, what would be a common denominator between those?
10.
10?
5.
No, wait, 5. 5.
Okay. So 5 would be a common denominator. Okay. So if I have a number like 30 and 90.
Would be 30.
Okay. Okay. So now when we're talking about the empirical formula, what we want to do is find the lowest common denominator, what we can divide both of the numbers into to get us a whole number to the lowest possible form. Okay. So let me give you an example. So we have C4H10. So C4H10, what can we divide this number by?
2.
You said 2? You didn't even give me a chance. Okay. So then if we divide both of these by 2, we get C2H5.
H5.
Okay. So that will be the empirical formula for C4H10. Piece of cake?
Yeah.
Okay, good.
All right.
Okay. Yep.
So if I have C6H12O6, what would be the empirical formula? Melissa, what would be the empirical formula?
It'll be C3H H6 and then 03. I mean 03. Oops.
Okay, good job. Piece of cake.
Yeah.
Are you sure that's the lowest form now?
No.
No? Can I divide it by anything else?
Yeah, you could divide it by 3 and that'll be C6H4 O2.
So if I divide this, can I divide this by 3? Can I get even smaller than this?
You could, but it'd be 0 and then that would be 2, 0.
What do you mean by it'd be 0?
So since you'd be basically dividing it by 2,
Uh-huh.
by 3, I mean, the 3 cancel out and that would be 0 and then the 6, you
Wait,
divide
but
by 3.
would it be 0 or would it be 1?
Oh,
Because it's an understood 1, right?
yeah.
So if we don't have a, okay, so then that would be 2.
And then
Sure.
1 and 1.
Okay, so this here would be the empirical formula because that's the smallest possible form that we can get. This guy would be an intermediate. That's not the empirical formula. That's not the smallest form. So if we divided all of these by 6, we'd end up with CH2O. Are you with me?
Yeah.
Okay, so let's do another. So if we have N2P4O4. What would be the empirical formula?
NP2O2.
Okay, piece of cake?
Yeah.
Yes.
Yeah.
Good.
Piece of cake.
Okay, so when you're determining the empirical formula, we're going to be determining the empirical formula using mass composition, and we're also going to be using mass in general. If we're using mass, the first thing that we want to do is convert into moles, because we want to compare the quantity of atoms to each other, okay? Not the mass of each other, but the quantity. So we want to convert to moles, and we know that moles are a quantity, right? So then once we convert to moles, then we're going to take the one that is the smallest, right? And we're going to divide both of our numbers into the one that's smallest, and then that'll allow us to calculate what is it, what are the atoms or compared to each other based upon that small number, okay? So it's hard to visualize, so let me give you an example, right? We'll go over it. A sample of a pure compound is made up of 1.61 grams of phosphorus and 2.98 grams of fluorine. Find the empirical formula of the compound. So what is the first thing that I want to do?
Add them.
Why would I add them?
To have the total, so then you can be able to take percentages.
So do I need to take percentages?
Yes, so then you can find out the formula, so you can know how many
Okay,
atoms
so
of each.
again, Diego, when we're comparing the formula, let's go back to our formula. C2 what was it? C2H5, right? So Is this comparing mass?
No, it's comparing amount.
What do you mean by amount?
How many atoms of each are in there?
How many atoms of each? So it's quantity, right? So why in the hell do I want to stick on mass when, because what you're having me to do, we're comparing mass, right? That's percent mass. That's not percent quantity, it's percent mass. So what was the first step that I said you need to do if you're given mass?
Find the molar mass.
Find the molar mass, okay, of what?
That not that compound, that substance or that element.
That element. Okay, so what is the molar mass of phosphorus?
Uh, 31.
Okay, so it's 31 grams per mole. So that's phosphorus. So what am I going to do with that?
Use that to find out how many atoms of phosphorus.
So am I going to actually find out the number of atoms, or am I going to find out the number of moles? Based upon what you're giving me here, what am I going to find out? Atoms or moles?
The number of moles.
The number of moles. Okay, so we're going to start off, always start off with what you're given, right? So don't run in circles. Start off with what you're given. You're given mass, the mass of phosphorus. So it's 1.61 grams of phosphorus. Okay, and now we use the molar mass. So I want number of moles. That's my goal, to get the number of moles, because I can use the number of moles to compare them to. Okay, so how would I calculate the number of moles?
Divide it by the grams per mole.
Divided by the grams per mole. So that means I put my grams on the lower part.
Yeah.
And then my mole on top, because then that would give me my answer in moles, right, of phosphorus. Good job, Diego. So I cancel this out. What do I get? How many sig figs should I have? And let me give you a hint. These guys are, so anytime you have conversions, right? And your periodic table kind of act as conversions, you're never going to use those for sig figs. So how many sig figs do I have?
Two.
Three.
Three. I have three. 1, 2, 3, right? Because we're not using anything from here as sig figs. So I have 3 sig figs. So my answer is 0.0519. Okay, so then I want to do exactly the same thing for fluorine. So tell me how I'm going to do it. Who's going to be my volunteer? We put Diego on a hot seat. He took my wrath earlier. Somebody else's turn. Man up or woman up. Come on, Erica. Woman up. Tell me, what do I need to do? Are you there, Erica?
You would take 2.98 grams of fluorine.
2.98 grams of fluorine. Okay. And then?
And then I forgot how we got the 31 for the last one.
Periodic table, molar mass. So what is the molar mass of fluorine?
19.
19. That's right. So in this case, we'd have 1 mole
Okay.
of fluorine divided by 19 grams of fluorine. So whenever I want to change my grams into moles, I'm going to use the molar mass. I'm going to use the periodic table. Okay? Tattoo that on your butts. Do not forget it. Okay? So I better see you guys all at the tattoo artist this week. Okay? So I get rid of my grams. And how many moles of fluorine do I have?
0.157.
Good job. And she even gave me the right sig figs. Okay. So now I need to determine which one is the smallest. Who's going to determine which one is the smallest for me? Which out of these two numbers, which one is the
Phosphorus.
smallest? Phosphorus is the smallest. Okay, so we're going to divide both of these by the number of moles of phosphorus, 0.0519 moles. And 0.0519 moles. Okay, so who's going to do that hard math for me? So 0.0519 moles divided by 0.0519 moles.
One.
Okay, so that means we have 1p. Now, 0.157 divided by 0.0519.
.02.
Okay, so can I ask you something? Can I have a 0.2 of an atom?
No. Okay, so 3.
Okay, good. 3. Okay, so if the number is 0.02, 0.08, we know in that case, we're just gonna round and then we're gonna have a whole number. So if it's 1, if it was 4, then we just use 1 or 4, okay? Now, if the number is, and this is what I want you guys to write down, and I want you to think about this and work with me. If it's 0.2, so for instance, if it's 3.2, then we need to try to figure out how can we make 2 a whole number, okay? So what can I multiply that 0.2 to make it a whole number by? All right, so what can I multiply 0.2 by to make it a whole number? If I could talk.
100.
100 would definitely make it a whole number, but we want the smallest number that we can multiply it by. The smallest number,
Oh.
not the,
Oh, okay.
okay. Yeah, 100 would definitely make it the smallest number that I can multiply 0.2 by to make it a whole number. If I had 20 cents, how many 20 cents would I need to make it $1?
5.
5. So I multiply this by 5. Okay. So if I have 0.25, what am I going to multiply it by?
4.
If I have 0.33,
3.
if I have 0.5,
2.
if I have 0.667,
1.5?
Not 1.5.
No. 1.3? No.
Not 1.3, but that's kind of close. Think about a whole number that I can multiply it by. So what is 0.667 in decimal and fraction form? Anybody?
2/3.
2/3. So what can I multiply 2/3 by to get rid of that 3 at the bottom?
3.
3. Okay, and let's see. If I have 0.75, what can I multiply 0.75 by to get a whole number? The smallest I can multiply it by.
4.
4 and 0.8.
$10.
That's the smallest I can multiply it by. How about 5?
Mhm.
You see the trend? 2, 3, 4, 5. 2, 3, 4, 5.
Mm.
Okay, so you guys are wondering what in the hell am I talking about? Let's say I had, instead of getting a perfect 1 here, I got 1. Well, let's say the perfect 3 here, I got 3.25 for my F. And I got 1 for my P. Okay? Let's just say kicks and giggles. So if I have 3.25, I don't want to assume that it's 3 because I have quite a bit here, right? Left over. That's a quarter. So that means that I should probably multiply it by 4. So I multiply this guy by 4, and I multiply this guy by 4 to get my empirical formula. So then that would give me 4P, and what would this be?
13F.
13F. Okay, so then my empirical formula would be P4 F13. Okay, so this empirical formula here is going to be P F3 for this answer. So do you guys understand how to use this table here?
Yeah.
Okay, so I'd write down that table. I put it at least on the side of my periodic table, so I remember that. Okay, questions, concerns, Cash? Okay, can I move on? Everybody got it down?
Yes.
Okay, so when it
Can we
shows
just do
up on
another
the
one like
test-
this, maybe?
What was that?
Can we do another one like this?
Yes, we can. So I'm going to give you a simple one.
First, you find the molar mass of oxygen and nitrogen.
Okay, so wouldn't I just start off with what I have, and then first thing I want to do is always start off with what's given. And then it makes sense to find the molar mass independently of each one. So this is grams of oxygen.
Yeah.
What is the molar mass of oxygen?
16.
16.
Okay. So what is it? Do I get?
6.7.
$40 divided by 16?
Oh wait, maybe I did it wrong.
It's 2.5.
Yeah, 2.5.
How many sig figs?
3. So 2.50.
Okay. And we have 28.0 grams of nitrogen. Okay, so what am I going to do with that?
The molar mass of nitrogen is 14.
Okay, so I'm going to divide by the molar mass. So 14
Yes.
over, so 1 mole over 14 grams. Okay, so what is that going to equal?
2.00 moles.
Okay, which one is the smallest?
Nitrogen.
Okay, so we divide both of them by nitrogen. The number of moles for nitrogen. Okay, we do the same thing up here, right?
Yeah.
Okay, what do you get?
1.25.
And down here?
1.
Okay, so what would be my empirical formula? Or do I need to do one more thing?
need to
The 1.25, you could times it by 4. So that's
Okay.
going to be 5.
So, and what I do to one, I have to do to the other. So if I multiply that one by 4, I have to also multiply the other one by 4. Okay, so let's go ahead and do that.
The other one's also going to give you a 4. The top one's going to be 5 and the other one 4.
Okay. So then we'll have 5 oxygens and 4 nitrogens. So then my empirical formula would be N4O5. Piece of cake?
Yeah.
Yes.
Okay. So let's move on. Okay, nicotine is 74.1% carbon, 8.64% hydrogen, and 17.3% nitrogen. What is its empirical formula? Okay, so let me put this a little differently, right? So, percentage is based upon what?
The part over a whole.
So in this case, it's going to be the part over a whole times what? So what is the highest percentage I can have?
100. So you
100.
multiply by 100.
Yeah, because we multiply it by 100, right? So the highest we're going to have is 100%, right? So 100% would be the whole. Is that correct? Like all together, it should add up to 100, right?
Yes.
Okay, I just want to be sure. Now, let's assume that I had 100 grams of nicotine. How many grams would be carbon?
We have to figure that out.
Do you really have to figure that out? Isn't it giving it to you?
There would be no
74.1%.
What was that?
There would be no carbon, right?
There would be no carbon? Didn't it just tell me that 74.1% is
Wait.
carbon? So if I have 100 grams of nicotine, how much of it would be carbon? Nicotine, not nitrogen, nicotine. Nicotine is composed of carbon, hydrogen, and nitrogen. So if I have 100 grams of nicotine, then how much of it would be carbon?
74.1.
74.1 grams would be carbon. How much of it would be hydrogen?
8.64.
And then how much would it be? How much would be nitrogen?
17.3.
17.3. Yeah.
Okay, now does that make sense? Okay, you guys can't answer. I'm done for today. I have nothing else to say. There's no lab. You guys are not responding. This is a waste of my time. I have better things to do with my time than just sit here and look at a dead screen and wait for people to sit there and decide whether or not they get it or not.
How do you got the 74.1 grams of carbon?
So if I assume, I made the assumption I have 100 grams, right? So if I multiply 100 grams by 74.1 or 0.741, I get 71 grams, right? Because it's percent mass, it's based on 100%. If it's based on 100%, all you need to do is change that percentage and we could just use grams.
Oh, okay.
Okay? That's the same thing here with the hydrogen. And that's the same thing here with the nitrogen. So by assuming that we have 100 grams of it, we can just change that percentage directly into grams. Okay?
Okay.
So then, and so we can sit there and make that assumption to make our lives a lot easier.
Yeah.
Okay? So what am I going to do next?
Change it into moles.
Change it into moles. So how do I change it into moles?
Divided by the molar mass of carbon, which is 12.
Okay. Okay, so if I divide that by 12, what am I going to get?
$61.7.
You mean 6.1? 6.1.
Oh, I divided 74.
Make sure.
6.17.
That's a decimal point. I know they're hard to see sometimes. Okay, so what about hydrogen? Mandy.
One mole of hydrogen is over 1.008 grams.
Okay, so
Hydrogen.
grams of hydrogen. Good job. Okay, so I know this is really hard math. Nitrogen.
You're gonna have your 1 moles on top and in the bottom the 14, so it's gonna be equal to 1.24.
Okay. Okay, which one is the smallest?
Nitrogen.
Nitrogen, yeah.
So we're going to divide all of them by the same, 1.24. So this gives me 4.97. So is that close enough? Or sorry, 9.8. Is that close enough to 5?
Yeah.
Yeah.
So we can say 5 carbon. This gives me 6.97. Is that close enough to 6? I mean,
7.
7?
Yes.
Yeah.
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 Thank you for correcting me. I appreciate that. And this one is a hard one, a big one. Okay, so what is our chemical formula and how would I write it?
NC5H7.
So that is correct. That would be one way of writing it. But typically, the way that you write it, carbon will always go first if you have an ionic compound. I mean, not ionic compound. If you have a covalent compound, carbon goes first, then you'll have your hydrogen, and then the one that is the most electronegative is going to go last. That's typically how you write the compounds, the covalently bonded compounds. So we'll put our carbon first, our hydrogen second, and then our nitrogen last. Okay. Question?
So, since for these, you just rounded it, right?
Yeah.
So in these cases, you round them if they're closer to that whole number. And if not, we do the table you gave us.
What's the closest? Yeah, what's the closest we can get when rounding?
Because like, what if it doesn't fall on the like in the decimal number, like on the table or close to it? We would just have to try and figure that out, or
Yeah. So if it's since these guys are 4.9, right? 9.8. That's pretty close to 5, right? That's 0.02 off. So that's 5. So that's not going to make a difference. But if your number is, because if you look at it, we kind of got it covered. If it's 0.9, you're going to round. You're going to round up. If it's 0.8, then you know that you're going to have to multiply it by something. If it's 0.7, you know you're going to have to multiply it by something. So anything that's from 0.8 to basically 0.2, so 0.2, you're going to have to multiply it by some number to get it whole. Does that help? So if it's 0.1, then you can round. Do you understand? If it's less than 0.1, round.
We round
it's
down though,
point-
right?
If it's greater than
Yeah.
0.9, round.
Oh, okay. Yeah.
Okay. Does that help? That's a good question. See, I like those questions. Those things make me happy. You can keep me happy, real simple. Ask questions, interact, respond, tell me I don't get it. You know, I may come off short, but I still want you guys to learn. The key thing is I want you to learn. Okay, are we good? We're good here? Pretty simple though, right? It's not too hard?
Yes.
Okay,
Yes.
so let's go one layer more. Okay, so if we're trying to determine the empirical, if we're trying to determine the molecular formula from the empirical formula, right? So then we will need the molar mass of the molecular formula, okay? So if we have the molar mass of the molecular formula, we're just going to divide that by the molar mass of the empirical formula. And then that's going to give us an integer to multiply our empirical formula by to get our molecular formula. All right. So you're probably at this point saying, what in the hell did he just say? Right? That's okay. I want you to say that. So let me give you an example. A compound with the empirical formula C2H5 has a molar mass of 58.12 grams. Find the molecular formula of the compound. Okay, so what am I going to do? So what am I given? Let me ask you that.
The 58.12.
Okay, the 58.12 grams per mole, that's going to be my molecular compound. Molar mass. Okay, and that's okay. Now the empirical formula is also given to us. Is that not? What is the empirical formula?
C2H5.
C2H5.
So if I wanted to calculate the molar mass of my empirical formula, how would I do that?
Use the periodic table.
I'd use the periodic table. How many carbons do I have?
2.
2.
I have 2 carbons. Okay, so what is the molar mass of carbon?
12.
2 times 12.
24.
Okay, hydrogen. What is the molar mass of hydrogen?
1.
5 times 1.
5.
And we add it together. What do we get?
29.
If I could do math today. (29 grams per mole). Okay, so this is the molar mass of my empirical formula. So to get the integer that I need to multiply it by, I just divide the molar mass of my compound by the molar mass of my empirical formula. Okay, so what am I going to get?
Two point zero zero or 2.
Okay, so I get 2. So then I take my empirical formula, my C2H5, and I multiply it by that integer. And then this gives me my chemical compound, or my molecular compound. Okay, pretty simple, not too hard.
Is this what we're gonna
No.
be practicing in lab?
Nope, this is not what you're going to be practicing in lab.
Okay.